What's so important about perceptual quality optimization for video? And the answer is really that I'm a firm believer that streaming video is the future of video delivery. And I'm also a believer, and I think there's statistics that we have limited bandwidth. And perceptual optimization is the ability to take advantage of how the human visual system looks at video versus how computers look at videos. So I spent 7 or 8 years on the MPEG committee, and I'm very comfortable with PSNR and SSIM and other statistical analysis techniques. But we found that through a lot of research over the years that the human visual system actually looks at different parts of the video than a computer does. And so we want to match that. And by matching that, you'll see that there's benefit. On the frame that you're looking at, hopefully you can tell that the right frame's better quality. It might be a little bit hard with the presentation, but it's pretty easy to notice that her hair is much clearer and her face is much clearer on the right. But if you could see a really high resolution version of this, you'd notice that his shirt is also much clearer in the background. So what we do is we analyze the video in real time, meaning that we're not a pre-processor or a post-processor, and in a very short window we're able to figure out the quantization parameters for the video and adjust those in any encoder that's compliant with 264. And what that means is we basically look at the video and we decide what's important, and we look at that, and that's red, and we decide what's unimportant, and we look at that as blue, and we will make fewer bit choices for the blue. And then you'll see some white blocks popping up, and the white blocks are where we're adjusting for motion, because motion's another critical factor. A lot of folks have worked in the contrast space, and from a standpoint of frame to frame, but you also need to take advantage of the opportunity from frame to frame in a motion setting. The unified map that we call it is in a very humble way, it's a breakthrough. It's many years of research in computer vision and image understanding. We take advantage of variance and luminance and edge strength, global motion, differential motion, contrast sensitivity, structural similarity, and artifact detection. And because it's so robust, I was not able to say that until today, because we have to obviously write patents on this stuff and make sure we're protected. The benefit with our first, and this is an introduction of our first product, the benefit for this is a 20% average bandwidth savings at the same quality versus X264, which is our base encoder. And we use the same settings for X264, including any of the perceptual settings that they would use to get the benefit. We have, we're not like X264 in the sense that we're not using a variance-based adaptive quantization, and we're not also like MPEG-4 where they might be using object-based segmentation from the background, although we have lots of experience in those areas in the history of the company. This is a picture, and I think a picture is 1,000 words. In the red, you can see that our algorithm notes that those are areas where we need to dedicate more bits to the encoding. Blue is an area where we've determined we need to dedicate less bits to the encoding, therefore reducing bandwidth. Are we complicated? Are we hard to work in the real world? We think we are not. We have developed an SDK API that fits into and can integrate into the quantization module of any X264 encoder in the marketplace. And one of our chores today is to find the right partners that can help us get this technology out to market. So we're fully compliant on the decoder. We also have a version of this for MPEG-2, but we are finding a real sweet spot in 264. We'd also be compliant to HEVC as that comes out. but we have so many prospects that are looking for help and a solution within 264 that we're really focused on that right now. Even though we're bringing a lot of the future of our technology in the company backwards to 264, we think the ubiquity of technology on the decoder side is still going to be very important. I'm going to play a video called Roller Coaster, and you're going to see the video play, and as it plays, we are modeling from a visual perspective what's important and what's not important from the blue perspective. And also we're using, within a few frames, the ability to analyze motion and do a better job of motion compensation to allow us to put less bits towards that application. Once again, we're doing a side-by-side, and in this case we're a little bit under a 20% bandwidth reduction, and actually the quality, even with reduction, we show superior quality. We're using VB rate control to do this particular example, but even on the left, where they're at 4 and we're at 2.8, you can see, even on this screen, I can still see the pixelation and whatnot on the left. So we think we've got pretty interesting technology, and we have, as a reference point, we had in our booth in the past 2 days, we had over 60 people take our test. So next thing I wanted to talk about is testing. Testing, I think, is everything to everybody in the compression industry because it's a complex industry. I came out of medical imaging and for 25 years, and I used to do things in medical imaging, and I thought I saw the most complexity of ever. It's mapping dose to source with grayscale and all this stuff, and then you get video compression. All of a sudden, you've got 30 frames a second one month and 60 the next, and they want 120, and your displays are changing. So how do you know when you've really got anything of value? So we spend a lot of time working on testing. We do it a little differently. We do subjective testing. So the chief scientist created a program that we use that many people today went through, and we have many testers that get into a very controlled environment and look at videos, and they rate them on a MOS scale, which is basically different than doing the statistical testing, but we think more accurate. But we take all the science we have to make sure that the subjective testing is as accurate as that can be. So if we have someone who tests a video that's very high quality and give it a 5, and they turn around and test the same video and give it a 1, we call those switchers, and you take the switchers out of your group of testers. This is not a new thing. Cable Labs a year and a half ago did a double-blind test for MPEG-2 that we took a part in, and actually gave us the idea that it's probably the way we want to go from a testing procedure. Results, once again, and very conservatively, we've got a 20% BD rate gain. That means that we test at 3 different bit rates for each video on an average, just like HEVC and the folks in that group do. We just take out PSNR and put in our subjective measurements for the quality. We've got gains now in some videos, even in videos that are industry standards like Park Run. We have a 43.1% bandwidth reduction. In Red Kayak, we have a 27.2%. We look at videos across every aspect of video that we can find. So we take the hard test videos that the video experts have. We take videos that are complex. We take videos that have a lot of contrast issues and spatial issues, and we take videos that are sports. Sports is a sweet spot for us. It's considered to be high motion, moderate complexity, and so we do very well with sports and whatnot, and we're not done. This was our first SDK API offering to the industry. We will continue to modify and work on the algorithms to to have further gains, and once again to help the streaming media, streaming video industry with its challenges with bandwidth reduction. And we think we can be a part of not only our company, but other companies being enabled to use new techniques to handle this. And I thank you all so much, and I hope everybody wins. Thank you.